Hi, we're back. We've talked about the human brain. We've talked about the human physical economy. This week we're going to talk about the human impacts on the natural world, the environment. This stuff can be kind of hard to hear, but I think it's essential for young people, for all people, to have a cohesive understanding of human impact on the natural world, on the oceans, on the biosphere, on other species. And we're going to give a brief summary of that right now.
Recall our simple diagram. Let's now look at the waste impacts from our economies. There are many examples of negative effects of our current economic system on people and cultures, but you probably hear about those topics in other classes. This video will take a fast and somewhat depressing look at some of the effects in the natural world, well, because it's important. Okay, before we get started, let me ask a silly question. What's a badger for? When I ask my students this, there's usually an uncomfortable silence followed by guesses like boots, a purse, a belt, etc. Because we tend to first or only think of the value of things as they pertain to human economic systems. Only after something has been harvested or processed does it have value to our current economic system, at least so far. A badger isn't for anything, by the way. It's an evolved creature living its life in Midwest ecosystems. Perhaps not to most humans, but it has value just as it is. Okay, some background. An externality is something not included in our market prices. In this short overview, we're going to break our modern environmental externalities into two main categories. Those linked to the metabolism of the human economy via our energy use, and everything else, which is our impacts on species and ecosystems. Okay, first, on the energy side, linked to the metabolism of the global human economy, we've touched on the massive benefits our armies of fossil workers provide us. These workers power our factories and machines. They're incredibly strong. They don't sleep. They don't complain. But as we're increasingly becoming aware, they breathe. Today, our industry, cars, and removal of forests are functioning similar to volcanic provinces of old. The amount of CO2 that civilization is releasing is not approaching the massive amounts that volcanic activity caused previous mass extinctions. But the increase from our human activity is occurring much, much faster. Most of you probably know the basics of global heating. Fossil carbon is geologic stores of past solar energy that we're re-injecting into the planetary system 5 to 10 million times faster than they were sequestered. The resulting and future changes to climate is simply a change in the planetary energy balance. Recall that oil, coal, and natural gas provide around 85% of the world's energy mix. This percentage hasn't changed in over 30 years, during which our total use and emissions has more than doubled. As a species, we've used more energy in the last 50 years than in all the 300,000 years previously we were anatomically human. And as a result, we now know that CO2 in the atmosphere is higher than at any time in the last 500,000 years or so, and possibly much longer. The top panel in this graph in green shows CO2 fluctuations over the past 500,000 years. The middle panel in red shows global temperature in Celsius, and the bottom panel shows global sea levels relative to today. Sea level is already some 400 feet higher than 20,000 years ago. The graph shows that neither CO2 nor global temperatures nor sea level rise has been stable. We are now in a no analog period. This graph shows the CO2 flux per year over time. If there's excess CO2 from either a volcano or a Volkswagen, it has to go somewhere. 88% of human CO2 emissions are related to burning of the ancient sunlight that accumulated over hundreds of millions of years. The other 12% is from land use changes, mostly removing forests and then releasing their carbon. About 30% of the total of these emissions is absorbed by land and forests. Another 24% is absorbed by the oceans. The remaining 46% of emissions stay in the atmosphere where they function as a greenhouse gas. Many of you are already aware that the years you've been alive are all the warmest years in the past 150 and trending higher. But what does this imply about the future? What do we know and what can we infer? We know that higher CO2 regimes will result in higher average temperatures, especially near the poles, more heat waves, more standard deviation of floods and droughts, more need for water, and agricultural impacts will mostly be negative, even though some crops like rice and soy will be expected to do better. As you might guess, the impacts get worse the higher the ultimate temperature change would be. For instance, at 2 degrees of warming, heavy rainfall events will increase in intensity by 7%, relative to a 5% expected increase if we stop at 1.5 degrees Celsius. Human energy use doesn't only influence climate change, but also poses risks to oceans. Ocean risk number 1. If the climate warms by 2 degrees Celsius, for example, the ocean levels are expected to rise 1/2 to 1 meter this century, with higher increases likely over longer time horizons. Many of the world's seaports would be inundated at a 1 meter sea level rise. Sea level rise impact goes much further inland than the water itself. The salinity affects agricultural land well inland. This will be very important in places like Bangladesh, where much of their land to grow crops is at low elevations. Ocean risk number 2, warming. Because seawater has absorbed much of the carbon to date, up to 90% of global warming resulting from human emissions has gone into the oceans. Warming poses risks to sea life. Coral species can't withstand extended hot periods. They start to die off, which diminishes reef diversity. Ocean warming also provides more heat energy, which makes hurricanes more intense. Ocean risk number 3, acidification. During the Industrial Revolution, seawater has experienced a 30% increase in acidity, approximately 100 times more rapid than at any other time during the last 650,000 years. Pteropods are small calcifying or shelled organisms that live as zooplankton in the water column. They're important prey species for many fish. An increase in ocean acidification can break down their calcium carbonate shell, ultimately leaving fish, cetaceans, and other creatures up the marine food web at risk. Ocean risk number 4, oxygen. There's been a 2% decline in ocean oxygen in the last 50 years. Warmer water affects the ability to dissolve and hold oxygen. Warming also impacts ocean currents, which transfer oxygenated water between regions. At the extreme end of some longer-term risks, some of Earth's prior mass extinctions were linked to times when warming at high latitudes stopped the exchanging of oxygen to the deep oceans, and Earth's oceans eventually became stratified with areas with little to no oxygen, called anoxia. There's lots of unknown risk and potential positive feedbacks are at play with the oceans. Okay, so how likely are these future climate and ocean impacts, and how bad might it get? As we're aware from the human cognitive bias section, pretty much everyone has an opinion. In your own zip code, you can probably find someone who thinks humans will go extinct in the next 20 years due to climate, as well as someone who thinks climate is a socialist scam and we're headed for an imminent ice age. The good news is we have tens of thousands of scientists working full-time on quantifying these issues, and the models they're creating are getting much better. But they're still just models of a complex system. Human emissions are currently around 1.7 watts per square meter of extra radiative forcing versus what's occurring naturally. Scientists have created scenarios of future emissions and natural feedbacks out to the year 2100 that range from 2.6 watts per meter all the way up to 8.5 watts per meter. By the way, the physical trends from these models don't magically stop in 2100, only the models do. The answer to which of these pathways we're on and which temperature rise will end up being our reality depends greatly on what the future of fossil carbon availability and economic growth will be. Most of the really scary outcomes we hear in the news assume we'll continue to grow our economies and fossil carbon use throughout the century, shown in the colored lines above. My personal opinion from researching this very deeply is that climate models are overly aggressive on fossil fuel availability, but also overly conservative on biological feedbacks. World government forecasts are generally for 2 to 3% annual growth in the size of our economies throughout this century. If something grows at 3% a year, that means it will double in less than 25 years. So in 2070, when most of you will be around 70, if economic forecasts are correct, the world economy will double in size not once, but twice, or be 4 times larger than today, and then 8 times larger than today by the year 2100. This would be horrible for the environment, but there's a serious question embedded here. Is such a forecast even realistic given the limits to fossil energy we possess? From an environmental perspective, if we're concerned about emissions, and we should be curious about several things. Number one, how linked is economic growth to energy? Could we decouple our GDP from energy and materials? Number two, how linked is energy to carbon energy? Can we decouple our energy use from carbon by switching to renewable low-carbon energy types? Number three, how likely is it we either choose to stop to grow or stop to grow involuntarily? Well, at least so far, global human economic growth is over 99% correlated with more energy use. Even the cloud is an energy hog. Currently, around 18% of our total electricity goes to powering servers, internet farms, laptops, and phones. So unless we change the definition of GDP, we're not likely to reduce the energy intensity much of the global economy. Carbon emissions and economic activity can be decoupled if we increase non-fossil energy production faster than we increase energy consumption growth. But despite the rapid increase in renewable energies, this is not happening yet, as we are growing total energy demand far larger than we're growing low-carbon energy on an absolute basis. The above graph shows fossil carbon annual increases in gray and renewable energy annual increases in green. The only year we subtracted carbon was the recession of 2009. To put it really simply, growing our economies will be bad for climate and oceans, and saving our oceans and climate will be bad for our economies. Is there a middle ground? We'll discuss that next week. But unfortunately, global heating and ocean risk are not the only environmental impacts. Okay, here's a whirlwind summary. If you take the weight of all the mammals on the planet, 96% of this total is now humans and our livestock, mostly cows and pigs. Wild mammals are now less than 4% of the total weight. If you exclude ocean creatures, humans and our livestock make up 98%. How doesn't everyone know this? This is a profound reshaping of the composition of living creatures. Populations of vertebrates, animals with backbones, have declined by 52% on average since 1970. The highest areas of threat shown in yellow and red are either areas of high biodiversity or high human population density or both. These declines are primarily to habitat loss and degradation, hunting and fishing, and climate change. Industrial farming, growing more food for more people, is also to blame for much of this loss of nature. Insects, or invertebrates, have decreased by 45% on average over the past 35 years. Over 40% of global insect species are now threatened with extinction. This rate of extinction is 8 times faster than that of mammals, birds, and reptiles. And according to the best available recent data, the total mass of insects is falling by 2.5% a year. If true, that's a crazy thing to contemplate. Intensive agriculture is the main driver of these declines, particularly the heavy use of pesticides. Urbanization and climate change are also significant factors. If you're like my 20-year-old stepdaughter, you really don't like bugs. But it's unclear that humans could exist without the ecosystem services of insects, since we've never had to. Insects provide pollination, pest control, nutrient cycling, decomposition, and food for other species. They are trillions of tiny robots doing jobs in our ecosystem for which there are no replacements. As a result, there's also been significant declines in global bird populations over the past 50 years. 2 groups of birds have been especially affected: grassland species, which have been hurt by the conversion of their habitat into farmland, and insect eaters, such as swallows and flycatchers. Over 5 trillion pieces of plastic are now estimated to float in the world's oceans today. At this pace, there will be more plastic than fish before the year 2050. Chemical pollutants are also impacting our own species. Sperm counts in Western males have dropped by more than 50% in the last 40 years. We don't fully know why, but the leading candidates are endocrine-disrupting chemicals from plastics, pesticides, and dietary exposures. In order to keep growing our financial representations of our success, We are simultaneously stripping value from the real stock market. We're increasing the goods, but not counting the bads. Being aware of who we are and what we're doing is the first step toward changing this. Think for a moment how delightful it is that badgers exist to share the planet with us. If you took a walk and encountered a badger or a bear or a moose, your day would be enriched. At the point we decide they have a value apart from what we might do with their bodies or parts, we may find that while not being for anything, they make the world a more interesting and valuable place which to live. We are related to every single living creature on Earth. The best estimate is now around 10 million other species. Most of us share a general feeling that our world is teeming with wonderful species that exist in harmony, as they have throughout all our human existence. This is unfortunately becoming less true, as wild populations diminish to smaller and smaller remnants of what existed as recently as your parents' and grandparents' time. We are not yet at a mass extinction event, but what is happening is that many populations are at risk, which in turn has cascading effects on ecosystems. Why is this a problem? Why does it matter if the sea's whales are replaced with jellyfish, swordfish with bacteria, rainforests with dry savanna, songbirds with silence? This is a question we each have to ask, because no value is assigned to these things in our economic system unless they're converted into a product which can be monetized. What is it worth to us to live in a world shared with ecosystems full of interesting, beautiful, and healthy wild species? Is it worthless or priceless? Can we even know what we've lost once the world's largest animal is the cow and butterfly migrations can only be found on YouTube? Everyone watching this video is alive at this inflection point, this brink beyond which biological systems may collapse in thousands of ways. Do we just watch it happen, or do we engage with these issues in ways more effective than anyone so far has managed to? One of my greatest joys is checking my wildlife camera every morning to see what creatures came through in the night. Over the years, there's been quite the variety. This was a fisher cat. I was so excited to know this creature lives in the woods by my house. After learning about nature and experiencing it, I no longer think of just a badger, but the badger or that badger. I think until we recognize and feel a kinship with nature, and this consciousness bubbles into our cultural value system and then our economic system, the trends I just outlined will likely not change. There are encouraging signs people are waking up to these problems. Unlike climate and ocean risks, which directly result from how much energy we use, many of the impacts in this video are a result of what we choose to do with that energy, so to some degree can be mitigated and changed. The entire European Union just banned single-use plastic items due to public awareness and pressure on this issue. We can and do make rules at local scales or with non-essential products to improve the environment. There have been many local and international success stories of social and political will affecting prices and regulations on products. The banning of DDT, chlorofluorocarbons, leaded gasoline, etc. are all environmental success stories. The question is how to do this on the macro scale. It is a truism that at a global level, the human economy privatizes gains and socializes environmental costs. It would be more fun to be in college and not be aware of the stuff in this video. But as the humans who will live and make choices during this weird century, I think you have to be. There's a huge amount of magic and beauty which is not yet lost, but which, as things are now proceeding, you will outlive. Is this acceptable to you? If it isn't, what are you willing to do about it? Okay, brief summary. Externalities are social and environmental costs that are not included in our market prices. Coal, oil, and gas burning and land use change are contributing to global heating. It is unlikely we have enough affordable carbon to reach some of these Armageddon climate scenarios, but it's a complex system. We don't know. The rapid loss of the natural world is at least as large a crisis as climate change, and it won't easily be solved just by switching technology. As a species, now is the time we must change our cultural consciousness regarding the web of life.
I think that living in the city of Minneapolis, I often get so caught up in urban city life that I forget about what's really out there, the reality, what's been there for billions of years, the flora and fauna and the biodiversity that make this planet so beautiful. And I think we need to consider that in all of our decisions.
I think the most beautiful part of our world is the natural world, is the environment, is all of the other species and beautiful things that exist in this world. And I think that we have a duty and a responsibility to respect and protect those resources and enable future generations of humans and other species to enjoy those things.
Here's some questions for your Nexus group. How do you feel after learning some of this information? Was there a specific piece of information you found particularly surprising or upsetting? Try and envision a society where the cost to ecosystems are incorporated into economic prices. What might this look like? Do you think it's possible? Have you experienced any extreme weather patterns or noticed environmental changes in the places you grew up? What is something in nature, animal, water, feature, etc., that brings you joy or has value to you, despite it not necessarily doing anything for the economy?